Okay, so on the previous video, we went ahead and got the total here of 8 hours. We took each number divided by 8 to get a decimal, multiplied by 100 to get a percent. And then what I wanted you to do is get all the degrees. So for example, I don't know, I could pick one of these, like say breaks. Let's look at breaks. So we took 0.5 divided by 8, and again our units matched because we had hours over hours, multiplied by 100, and we got 6.25%. So to create a percent, you divide, multiply by 100, but to use it, you're going to put it in decimal form and multiply. So when you use percent, you always multiply, and we're multiplying it by 360 because we want to know how many degrees of the circle breaks gets, which ends up being about 22.5 degrees. So you need to figure out the percent for all of these and the degrees for all of these. All right. And so once you get them all, then you kind of need to go around and draw these. So for like meetings, you know, it's about not 90. So it's about what? Meetings end up being about 68 degrees. So then I put meetings, and I would put the percent on it though. So about approximately, I'm just going to put 19%. Okay. And then notice that off task, is that the same thing as meetings? Meetings is what, yeah. So I'm going to go ahead and do my off task while I'm at it because they're actually the same. So I'm going to try to make them the same. So off task would be also 19%. And then let's see, what do we have? Lunch and calls were the same. They're 45 degrees. So together they should make 90. And so let's see, how do I want to do that? So I kind of need to visualize like a right angle here. So there's 90s, so maybe split that in half. All right, so then what are those? Those are 45, 45. So one is calls and one is lunch. So calls, lunch. And again, you want to put the percent in there. So the percent for lunch and calls was about 13%. You could put 12.5. All right, what do I have left? Breaks were about half that, so if I can kind of eyeball breaks maybe. Again, obviously this would be easier not doing this on a computer. And breaks were what percent? About 6%. And what's left? Computers are left, and they should be 112. So see how this is more than 90, so that looks about right. So computers. And what percent did we get on that? About 31%. So there should be no gaps in your circle, like every space should fill up. These should add up to 100%, but again, with rounding, sometimes that doesn't happen. So we have labels, percents, and then Ian's day. Now, obviously, if I was a boss, I would have some concerns here, because as I look at this, I'm like, okay, well, off task here, lunch here, breaks here. I'm hoping the computer time is work time, but not certain there. So Ian might need to be a little more productive as far as I'm concerned. All right, let's move on to bar graphs. A bar graph is when we want to do part to part. So we want to compare, like, here's my little bar thing. I want to compare how, like, this amount to say this amount to this amount. All right. And your bars do not touch typically, or they shouldn't touch. If they touch, they're more of a histogram. Again, we would have a title. We would have gaps here in between. And these are usually categorical data, like, you know, green M&Ms, red M&Ms, and blue M&Ms. So you just kind of have different categories. So my label down here might be M&M color or something like that. And then this one would be frequency or the amount. So maybe, you know, I'd have consistent units here. And these have to be consistent, but they don't necessarily have to go to by 1. So you have to start 0, but you could go by like 2s, like 2, 4, 6, 8, 10, 12. Could go by 5s. As long as you have a consistent unit, you're good. All right, I'm going to pause here, and then let's flip the page. One other thing, I guess, before we go is a Pareto, I think I'm saying that right, graph, is when we do a bar graph, but we go from like high to low or low to high. So that way things are in order, which is kind of useful. So pause, flip the page, and we'll get back together here. Okay, so on the next page, they look at the state and then average gas prices. And if you notice at the chart up here, they're alphabetical. So someone could make a bar graph and put states and start with Alaska, then California, then Hawaii, and so forth, and go alphabetically. And then notice we have this little gap thing here again, and that's because they didn't want to go by, say, 10 cents, 20 cents, 30 cents, 40 cents, 50 cents, 60 cents, and consistent units until they got up to like a range of gas prices. So they skipped a bunch, and since $2.97 was the smallest, they decided to start at $2 and go by quarters. They could have started at like, say, I don't know, like 260, 270, 280, and then gone by 10-cent increments or even 5-cent increments. So if I started at, say, 260, I could have done 260, 270, 280, 290, $3, $3.10, $3.20, $3.30, $3.40, and so forth. So as long as you have consistent units, you're fine. But if you skip, you need that little zigzag guide. So again, see how the bars don't touch because they're categorical. And notice this is what we call a Pareto chart because they went in order. So the reason this is better than alphabetical is because then I can look at it and say, oh, California has the highest gas price, then Alaska. So they're in order, so I don't have to really analyze them. I can just be like most expensive, second most expensive, cheapest, and it's all in order. So that is what we call, if I can get there, a Pareto because it's easier to see. All right. Okay, let's look at the next page here. All right, there they give you an example. This is typically when they touch like this, it's more of a histogram. So a histogram is more when you have, like, say, 0 to 1, and then as soon as you go to 1, 1 to 2, and 2 to 3, and 3 to 4, and 5. So I would kind of say that this is a little iffy as a bar graph. So that's my opinion. Usually bars don't touch. And again, see the nice little video thing up there. So if you want to watch the video, that would be a great idea. And that's under multimedia on your book in my math lab under course content. So you can click on multimedia, find the videos, and go from there. All right. So let's go to the next page. All right. So now we have what we call a line graph. So what you want you to do is read this and try to answer all the questions. We're dealing with some tablets here, and looks like they have to take 2 of them to get up to 1,000 milligrams, and adult liquid, so it looks like they're taking 2 doses to get up to 1,000. So read the part up here, and then answer all the questions on the bottom of that page. Okay, I'm going to pause. You do that, and again, don't cheat. Do it as if you're in class, and then come back. Okay, so the only thing that this graph is missing is a title. So I don't know if they're considering this. This is more of a legend to me. So they probably should have like liquid versus tablets results or something like that. So they're kind of missing a title there. All right. So what does that ordered pair mean? All right. So what is that? All right. So let's look at this. The ordered pair is what? Over 2. We always do x first, and up about what? 12? So what does that mean? All right, so it looks like the X is hours, so it looks like after 2 hours, so after 2 hours of taking the meds, and what kind of meds is it? The tablets, so 2 hours after taking the tablets. So after 2 hours of taking the tablets, then this 12. So what's the label on 12? Well, this is micrograms, which you might not, that's not a U, it's like a mu, it's kind of a Greek symbol. So micrograms per milliliter. So that's actually how much of it's still in your blood. Like if we did a blood draw and we measured the chemical or the medicine in your blood, this is the concentration that would be in a milliliter of blood. 12 micrograms per milliliter. All right, B, use the shape of the graph to describe what happens to the concentration of the medication in the body over 8 hours and why a second dose is needed. All right, so if we kind of look, what's happening here is that at first it peaks a lot, right? But then it kind of, it starts to go down, correct, in this kind of 4 to 6 hour time period. And so if we want the same peak again, or that same pain relief, we're going to have to take a second dose to get that up again. So it does pretty good. The first 2 hours is really great. And actually the first 4 hours isn't too bad. But then if you look by 6, we're kind of really dropping off. So that's why we need a second dose. When do the 2 formulations have the same concentration? Well, And sometimes people miss this, but for sure at the beginning, right? Because you just took it, so there's kind of nothing in your bloodstream yet. And then it looks like about right here they cross, so that'd be about at the 45-minute mark. And then it looks like the lines are on top of each other at that point. So for that one, I would say 0 minutes, 45 minutes, and then kind of the 6 to 8 hour mark. All right, let's look at the next page. So pause and... Okay, so question D on the next page. Based on the graph, which would you take for pain relief, liquid or tablets? Explain your answer. So if you look at the blue one, let me try to see if I can get blue. So the blue one peaks really high and then, kind of slowly waves off. And the orange one, I'm going to kind of use red here, doesn't quite peak as high, still peaks. Okay, and I'm obviously not a very good drawer. So it kind of depends on those of you that have different aches and pains. If you have something that happens where you're in a lot of pain quickly, maybe you, I don't know, twist your back wrong and you get that shooting pain, or you twist your ankle and you get that shooting pain, you might want the blue one, which is what, the liquid, because it gives you a little more pain relief faster. But later, it's actually lower than the other one. So if you want the quick relief, you're probably going to want to go with blue, which is liquid, because it gets in your body a little faster. All right. If you have a nagging injury, so you have a back injury that you've had forever, every day you wake up, your back hurts, muscle pain, things that are kind of ongoing, then you might want to do the tablets because, yeah, you don't get that instant pain relief as high, but still not bad. But for a long time, you get a little bit more pain relief, a little bit more stays in your system. And at the end where they overlap, you're going to take a second dose anyway. So this one's going to give you a little higher, kind of more continuous pain relief. This is going to give you that quick. So it kind of depends on what your injury is. All right, go ahead and try E. So pause, try it, see how it goes. Okay, so let's look at this next one. Now, rates are super nice because you can scale them up and scale them down. So we have milligrams per 15 milliliters. And we're going to scale it up because they are going to take, 2 doses to get to 1,000. So we're going to scale it up to get 1,000 milligrams, which is 30 milliliters. All right, and so now we need to figure out how many tablespoons this is. Well, each 15 milliliters is the same as 1 tablespoon. So if you have a tablespoon here, that's 15 milliliters, and another tablespoon, that's 15 milliliters. So that 30 is really going to be the same as 2. So they would have to take 2 tablespoons of that. All right, so a couple things. Line graphs, all right? We use line graphs when it's the same data going up and down, and you do connect the data. So like you have different points in time. So this would be like maybe my weight going up and down over the years, or maybe it is my temperature, or my heart rate tracked for, say, an hour period. It's not going to be different people. So if you have different people like, oh, so-and-so, her weight is this and their weight is this, and we're tracking a bunch of 50-year-old women's weight that are all the same height, that is not going to be a line graph because those are totally different people, so it wouldn't make sense to connect the dots. So it has to be like the stock market, like target stock. It starts at this value, it went up, it went down, it went up, it went down, it went up, it went down, and it went up. But it's the same company stock. If I'm looking at a bunch of different people's stock or different company stock, it wouldn't make sense to connect the lines. Okay, so when do we use a line graph? If we go back, let me get out of here quick and go back. So if you look right here, a line graph is connected order pairs, all right? And again, typically we're showing change over time is what we're typically doing, okay? But you connect the dots because it's the same thing going up and down. Like this is the same dose, and we're keeping track of it in one person's blood, and the same dose, and we're keeping track of it in one person's blood. But again, consistent units, so like notice they went by 3s all the time. Label, 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 and again, you need a title. All right, we're not going to do the last problem. So for page 73 for homework, you need to do 1 through 3. So 1, 2, 3, and then 5 and 7. So 1, 2, and 3, 5, and 7 for this section.